Alrighty, El Rudy. Welcome to this presentation about what the Music 420 Capstone project could be for January of 2025. This year, because of the number of people who have indicated they're interested in the capstones, and because there's this correlation of number of people and what can be taught, this year, if people are interested in doing a hardware capstone, it's going to be taught in a class format, as I say here, rather than individual meetings. We can't possibly handle all the people who want to do a capstone as individual meetings this year. So I'm proposing that the class is going to meet in the computer music studio. We have the electronic workstations there with all of the tools that are required. And we'll meet for a few hours each week. And it's best, I think, for people's schedules if this is at a time in the evening that's convenient for everyone. And as I say here, Sunday, Monday, Tuesday, or Thursday, unless you really want to miss out on evening concerts or whatever, and you've got nothing better to do on Friday nights. I prefer these other 4 days, choosing that. So the actual day will depend on who expresses an interest in doing one of the capstones and what their schedule is like. Now for this project, I'm proposing that everybody builds a controller. And this will be a wireless controller interface. It's going to have 3 to 4 pressure sensors on it. It's going to have a slider controller on it. You can see the finger on the slider controller down here. This is a pressure sensor here. And it's going to have LED strip lighting. And it's going to use the Arduino Nano board. And inside that, there's an accelerometer and a gyroscope. And it also handles the wireless connection to your laptop. This is what I propose that the controller can look like, or somewhat like this. As you can see, there's a piece of ABS pipe here. That's like basic plumbing pipe, and this is going to be about 2.5 inches in diameter. And on the top, there's a project box, and inside that there will be a USB battery, a proto board, and then the Arduino Nano, which has the gyro and the accelerometer in it and handles the wireless. Then on the board itself, there will be 3 to 4 FSR sensors, force sensing resistors. These get stuck on. Below that, there's a soft pot potentiometer that you can slide up and down on. And then for some eye candy, I've added some addressable LEDs. Now, you can use this controller, as I say here, to send performance data to your Max MSP jitter patches or to Unity. You can also control all kinds of things from the data that's in this. For instance, the data from the FSRs can be used to trigger particular samples, or they can send continuous pressure data that you can use to change parameters such as brightness or cutoff frequencies and filters, or the amount of resonance in a patch, or a C to M ratio, things like that. The soft pot you can use in the same manner, but you can also use it to scrub backwards and forwards through samples, or you can use it to increase or decrease brightness of a sound or of a lighting controller. The accelerometer, which is will be inside this, you can use it, for instance, to trigger percussion patches by slamming down. Actually, because you can trigger going this way or 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 this way, there's actually 6 different ways you could control. So you can control different percussion sounds with it, or you can use it to start a bed track that might play for 30 seconds or a minute, and then you can play over top of that using the other data, using data from the other controllers. You can, as I mentioned before, you can control DMX lighting with this. You can send control data to Unity to control things. There's all kinds of things. Once you've got your digital data and it's in Max MSP, you can do whatever you want with it. Now, as part of this project, the expectation is in the first half of the semester, you'll be assembling your controller and learning how to write code for it, which is not a difficult thing to do. And then you're going to, in the second half, you're going to work with your group and you're going to create an ensemble piece that will get performed at the Bang Festival. And each performer, you're going to be writing your own Max MSP patches. You're going to have a different type of instrument. They'll look the same, but they will do different things. And you'll be able to create, I think, a really interesting ensemble piece for performance. Now, as part of this, as we do with all of the capstones, each week you do a documentation on your own website that you've created showing what you've accomplished. And this includes pictures and videos, little bits of text showing how things are progressing, what problems you've encountered, and how you've solved those problems. At the end of this semester at the Bang Festival, the entire group is going to give a research presentation talking about the particular approaches that you've taken, what problems you've encountered, and as I said before, how you've solved those, and what your particular patch does and how it works using the data coming off the controller. Like all of the Capstone projects, we hope that you're able to use the outcome of your personal work, be able to use that in future projects, performance projects, installations, whatever it is that interests you. This is my estimate of the costs to build a Capstone controller, this Capstone controller. It's about $85. One caveat here, I've got the project box at approximately $12. If we can't find a project box that's the right size, or if we find ones that are just way too expensive, we may end up having to 3D print the project boxes for mounting them on the ABS pipe. Also, we're using USB batteries, power bank USBs. This means that you don't have to go through the process of working with a voltage regulator and calculating how to work that into your circuit and adjust the different voltages that the Arduino board works on and that the addressable LED lighting works on. So if you're interested in doing this, Keith and I need to hear from you in the next 2 weeks, essentially, if you're interested in doing this project. Then based on the number of people who have indicated they want to make a controller, I can calculate the individual costs, tell you how much you need to give me, and then I will go and order all of the materials required. This just makes it much easier than having you chase after materials, and you may not know specifically when it comes to certain differences in the materials what it is you should be buying. So it's cheaper and faster and more efficient if I buy these things. By doing this, by getting this nailed down in the next couple of weeks, we'll be able to start in January. And immediately what you're going to learn to do, it seems a little off, you're not going to be working on your board, you're not going to be working with code. The very first thing you need to do is you need to learn how to solder. So we're going to start working with, in the computer music studio, you'll learn some basic safety techniques, you'll learn how to work with soldering, and you're also going to learn how to read resistors in that first week. And then you've got a little thing to work with in terms of getting your skills up and being able to work with some basic electronic formulas. One formula. Okay, I hope this is helpful. Let me know, ask Keith questions. Let me know if you need any more information. Everybody ropes, everybody rides.